Hi, my name is Mariam Katartani. I'm 7th semester mechanical engineering student, and here I would like to present to you. My friends and I have built a mini air conditioner with a fan, a pump, and of course with another stuff. Here we go.
The video presented is my main project for the Senior Mechanical Laboratory course at Sampurna University. Hopefully it designed very detailed about the preparation, the timeline, what happened before, during and after the experiment. During the pandemic, learning scope should be adapted, even the laboratory activity we could be doing at home. Big thanks to our engaging lecturer, Mr. Jati, for always giving us the support, beloved Sampurna University that already facilitated us, and my cheerful teammate as well. To make it become realistic, a timeline always works well, starting from the proposal agreement, shopping, shipping, until the experiment day. At first, the proposal agreement. As a group consists of 3 members, I am with Muhammad Bayunur Akbar and Astrid Fanya Okhtari, had conducted brainstorming, discussion, and desired proposal. The proposal should contain 3 modules, which are fluid analysis, heat transfer analysis, and thermodynamics analysis. That is why we decided on a mini air conditioning system as our interest to learn the process inside. Second, shopping is always interesting and a fun activity for me. Let's just move on to the list. Here we are. To build a mini air conditioner, these are the list of components and the estimated price from our research. On that day, after collecting all the kind of stuff, mostly from the online commerce, it takes 1 until 2 weeks to get along the component with us. Third is about the shipping process. After collecting all components, the shipping works well as planned. With this kind of track system, the pathway was purposed to minimize the cost. We can use only one setup and make it move as planned track system because we are at different places, even province. However, we have done this way as the chart show here, so everyone in the group received the setup completely. At the experiment day, I received the package. This period is consumed about 10 days. Based on the schedule, we have sent the package to wrap the setup in between teammates in a group. At certain time, each person in 2 weeks can follow the assembling process, consultations, and data collection and calculation. Another 4 sections of contents. But actually, this is the main contents which more or less discuss the system in a series analysis using fluids, heat transfers, and thermodynamics principle. Let us move to the first. Let's start from the laboratory greetings. Commonly, an air conditioner is a system that is used to cool down a space by removing heat from the space and moving to some outside area. That was the most common type of an air conditioner system. However, the difference here is that the experiments only use water as the liquid and there is no condenser at all. The next is the assembling process. Hopefully, the figure on the left can show you the whole illustrations what is the system look like. Let me play this video. I make sure the type of the valve and rubber hose using pipe type to prevent any leaks. I make sure the valve is open and made the water can flow through the pump. Put everything on the container with cold air and the ice cubes. For the next, positioning the fan right above the container, and I set the height of the fan head that has been pinned on a circular pathway of the copper hose. The fan became heavier, so I tied the bolt on the back of the fan. Finish with the rubber hose that comes from the pump and the one that will return to the container. Make sure the plasticine covered the holes from the air that was coming in and out. By giving a thermometer to the system, we have a complete setup circuit of mini air conditioning system. After finishing the previous chapter about the laboratory greetings and the assembling process, I'm going to analyze about the fluid, the water flow inside the hose. We're expecting to compare the flow rate and the flow velocity at some point along the hose. Flow rate and flow velocity at point A and point B is the objective in this slide. Here are the assumptions that I use in this kind of calculations and analysis. And I can get the pipe sections area using diameter is equal to 7 mm, and I use this formula to calculate the flow velocity. I use different kind of data collections approach to have flow rate and flow velocity at point A and point B. A, I got flow rate from the pump's manual book, but I need to convert liter per hours to become meters cubic per second. And to find the flow velocity, I need to divide the flow rate with the area. And at point B, I use a measuring cup of approximately 80 grams, and by using a timer until the glass is fully filled, it takes 60 seconds. So the flow velocity at point B is equal to 0.035 meter per second. The result that we got here is a drastic reduction due to the phenomenon of water rotating along the hose. Next module, we are going to analyze using heat transfer principle. During the temperature change, there is heat transfer moving on because of the fan and the pump keeps flowing the cold water. Reflecting to the air conditioner behavior, the system expected to replace the hot air. It considered by the existence of the CPU fan. The complete cycle shows that the hot air enters the container with cold water and ice cube. With help from the pump, cold water can be distributed along the hose, either rubber hose or the copper hose. Why it used copper hose at this position? Because copper material it is a conductor. It tends to stick the cold temperature longer than the rubber. So the fan blows the cold air and fills the room with a cold temperature. This data was collected with some conditions where the CPU fan and pump always on. The fan above the container is turned on and off over the time. Because there is only two thermometers, I place the first thermometer at the copper right in front of the fan, and the second thermometer is placed 1 meter in front of the fan. So the water temperature here is separated experiment only about 15 minutes. That is why the water temperature here is blank. At this table shows here that is always decreased by the time change. It becomes steady at 40.1 Celsius in 6 minutes. With these two graphs from the previous table, we can compare air temperature, the gray one, with the copper temperature, the orange one. While the fan turns on, both thermometers shows the same characteristics. It was getting lower respect to the time. However, the copper temperature while the fan turns off, it getting lower most likely. The temperature decreases faster than when the fans turn on. While the air temperature has increased, this result is due to insufficient cool air reaching the second temperature. We can conclude that the air from the fan may contain hot air too, so that when the fan is turned off, the copper temperature has a lower temperature. It means air blower from the fan not always producing a cold air, but the blower brings also the hot air with them. Last module, using a thermodynamics principle. Instead of calculating the efficiency of the system, we are able to calculating coefficients of performance or COP of the system by the data collected. By assuming the cycle as a reverse Carnot cycle, from both the cases as shown on the last table, we can compare the coefficients of the performance or COP when the fan turned on and with the fan turned off. To this source, the conceptual value of a Carnot cycle is that it establishes the maximum possible efficiency for an engine cycle operating between the hot temperature and cold temperature. In the cycle, temperature in Kelvin is used in order to calculate the COP of the cooling process. As you can see from this equation, as the difference between the hot temperature and cold temperature increases, the COP becomes lower, and vice versa. This means that an air conditioning system is more efficient when the room temperature is closer to the outside temperature, and will use more power when there is a large difference in this temperature. And actually, the ideal COP values for air conditioning system and heat pump systems are in the range of 2 until 4. In two cases, while the fan turned off, the COP is lower than when the fan is turned on. Those two cases are not matched with the ideal number of COP, and we cannot compare to the typically cooling process because of the resulted COP number is too big. I think the errors are available because the experiment is not long enough. Reaching the conclusions and sums up everything briefly. We have done this experiment to build a mini air conditioner, so the experiment runs well, even not in a perfect way. From those three modules, we have assumptions to make it more understandable because we need to analyze it, so we need to assume it and make it more understandable. And for the next, of course, the thermometer is actually an aquarium thermometer. It is not proper because takes so long time to reach a certain temperature. It was an error, I think, in this experiment. And the next is the rough data seen on the graph at the last slide, because it was imputed manually and close to the human error. The last, even it is hard to do, but we have done this thing. We can do the laboratory activity at home. Really, the last from this video, feedback for the future class. It was great, we can do the experiment on our hometown, but it was not satisfying for me. The learning outcome is not really satisfying because in the first class, if we are in the first class, face-to-face class, we can learn more and having fun more closer with the mechanical stuffs. However, I'm happy we can still conduct the laboratory and prepare by ourselves and do this and that by my own. And for the citation, I think uh, it was better if the topic of the experiment is same between the groups, but it has discussed and choose the best. So we can more predict whether the data collector's approach is correct or not. The discussion could be easier because we can compare and ask in a correct way. Thank you, Mr. Jati. So this is my team member in a group. We have done the same thing to build a mini air conditioner or homemade air conditioner. Thank you for your attention, and this content belongs to Slide School.